Great. Hey, everyone.
Brant, hello, welcome.
How's it going?
Fantastic. It's been a fun day of learning for all
Awesome.
of us here. So I think to start out with, we should start with maybe what is Titan before we get into the embeddings part.
Sure. Yeah. So Titan is the Amazon first-party models, large language models. The generative models right now are in preview, and the text embeddings model is what we've announced as generally available alongside of Bedrock, the announcement with Bedrock on 9/29. So it's our first-party models that are available inside of Bedrock. We have our third-party models, and now we also have our Amazon Titan models too.
Awesome. And so as I kind of led with embeddings, what are they? Why are they important? Why should we care? Should we care? I'm assuming the answer is yes.
Yeah, of course you should care, and it'll tie a lot of things together with what Harshal just went through with the knowledge store and connecting to external data sources. And embeddings is basically being able to represent a body of text numerically. So if you had a text, you'd be able to see it as, I think about it as like a row of an Excel file. And so the input into an embeddings model is some paragraph or some period of, text, we call them tokens, but the number of the words that go in. And the output is some numerical vector. The numerical vector is called an embeddings. The terminology can be kind of scary sometimes, but basically it's taking a body of text and representing it as a row of numbers. And the reason why this is super powerful is because you're able to create databases of these vectors and then do things like search or find similar documents. The most popular one is to be able to do search. So if you give a query, you'd be able to retrieve a passage that is most numerically similar to your search query. And when you tie those together with large language models, you're able to take in the passages that are most similar to your search query, populate them as part of the actual model prompt, whichever model you're using. And then the model can actually read all of the passages and answer your question for you. So you don't actually have to read through, pages and pages of documents. You can just have a search query go and retrieve all of the documents that you want to have. And then the large language model can actually just read it and give you the succinct answer that you're looking for.
Super cool. I'm sorry that for those I know were complaining that my mic is not great. I've had some issues with my Wi-Fi this morning. I was fighting it. Haven't won that battle yet. But the show must go on. So we've got numbers. Text turns into numbers, are embeddings.
Yes.
So what are Titan embeddings?
Yeah, so Titan Embeddings is our released model that actually turns these texts into numbers. And so the Titan text embeddings model can actually take in up to 8,000 tokens. You can think about this in the range of like 6,000 words, and then actually output a vector of 1,536 numbers. And so it can do that on a consistent basis. And when you want to create a database of, let's say large amounts of documents that you want a large language model to query over, you can do so with Titan embeddings. You can do it at the large, up to 8,000 tokens in one go, and it will just create those vectors for you. Input is the text, output is numbers. And then that allows you to do things like search or find similar documents or anything like that.
There were some questions in the chat that I think we should address first before we go further, because there are some foundational questions about embeddings. So Eduardo was asking, so would that be like assigning a serial number to a body of text?
That's a good way to think about it. Yeah, it's not necessarily a serial number in that it's only assigned to that body of text, because it's more like I think we were talking about this, before, where it's like almost like a cipher, where it's like the model has somehow like figured out what this text should look like in a numerical setting. So if you assign it as like a random serial number, like a barcode, then it's sort of not really affiliate. It's only like tied to the text, where it's actually what the model's doing is actually creating a unique serial code based on the text itself. So if you slightly tweak one word, you'll have a different set of numbers, a slightly set of different numbers, but it will still be the same, relatively very, very similar to the original text that you had. So it's not quite a serial number, because a serial number like the way that I think about a serial number is more like it's just a random alphanumeric string. It's not really that way. The model is actually, creating a very specific set of output numbers based on the text that you input.
So good.
Yeah. But when I think of a serial number, it's like it does identify a specific, thing, but in a serial number, usually the numbers themselves don't really have meaning. Is that kind of accurate? And in embeddings, the numbers do have more meaning.
The numbers have meaning. The model is basically what has coded the meaning into the numbers. So we trained this model to figure out the meaning of that text in a numerical way.
Got it. Awesome. So we went through this part of the why. What can you tell us, like, some of the use cases? I've heard, I don't know, RAG, like, is that something you wash your car with? Like, I'm not catching on with that.
So RAG is the technical term that stands for retrieval augmented generation, which also sounds super fancy. Basically, what this enables is, I think, in some of the questions that we had when Harshal was up was, how do we connect this to our own websites or our own data sources or anything like that? Basically, what this enables is the ability to search over documents without actually having to, and have large language models read your own proprietary documents or potentially current events and synthesize the results for you. So it's a way to connect large language models to external sources of data that are, could be proprietary or more current, that the model wasn't necessarily trained on itself. And that is what's retrieval is. You're going and finding the relevant information, and then you're augmenting the prompt with your data, and then the model is generating the result. So retrieval augmented generation.
Super cool. Yeah, I definitely want to see this. So I'd love to see a demo. And there's also a question that would be great for you to answer as you're going through the demo, because 23 Synapse was asking, is it just a general search function? And I'm wondering maybe if maybe the demo might help explain that answer.
So let me go through the demo and you'll see the differences here.
Yeah,
so,
exactly.
Okay,
Perfect.
So let me know if I'm sharing my screen. Perfect. Okay, so the first thing that I'm going to do is I'm going to create a database of whatever data that I have. So what I've already done is I've pre-populated a database with some of the user guides from Bedrock. So here's a passage. Features of Bedrock with features of Amazon Bedrock. Here's another passage. Amazon Bedrock is a fully managed service. Here's another passage. Provision throughput. So if I'm going to create a database, basically, I mean, this is a UI version, and if you're going to do this over millions of documents, you're going to automate this. But I'm going to just add a vector to this database. So here I just pasted this, and I click create, and I just created a numerical representation of the body of text that I just did. Now to test this, I'm just going to go to text. And then I'm going to type my question here. Let's go with, what is provisioned throughput?
And so for those who are watching, I know someone was asking if this is pre-recorded. This is live. So James and I are looking in the chat. So if you've got questions, we are here in real life. Some people think I'm in an underground sea base because of my bad audio. But yes, we are live.
And so that also shows by like mistyping or misspellings into this live demo as well. So so I created a database. I created a vector, and here you can see the all of the text. So when I typed in what is provision throughput, when I type this in, what we're actually doing under the hood is we're comparing the set of numbers that were created. So the embeddings that were created for this body of text, what is provision throughput, to all of the embeddings that were created for all of the documentations or all those passages that I just showed. And here on the left-hand side, you see the score of how similar this query is to any of the bodies of text that I retrieved, that I created. So if I click on this one, you can see provision throughput, and here's like information from the user guide on provision throughput. And it has a 72% match to my exact query. Now, if I went to the bottom one, you would see Brant is a product manager for text embeddings and Rashita is the principal scientist. So here, this is only a 50% match to the actual query. And as what I've gone through here is what's happened is I first created a database of all of these embeddings, all of these numbers that represent all of these passages. And then I input a query into this that was, what is provisioned throughput? And that was then created, that query creates its own set of numbers. And then we compare all of those sets of numbers together. And the top most similar passage comes to the top with this 72% mark. So this is what is provisioned throughput. Now, why is this powerful is a separate question, because here I'm showing you passages and then you have to read what this is, right? So like maybe this is a lot of content. So instead, when you actually combine this with a large language model, what ends up happening is I'll ask the same question here. What is provisioned throughput? And that passage, or the top n number of passages, are being populated into a large language model. That model is then reading all of those passages, so I don't have to, and then giving me a synthesized result that tells me exactly what it is that I requested. So here you see the model output. Provision throughput refers to a level of throughput at a fixed cost that you receive when configuring it for a model, allowing you to receive a discount rate when you commit to longer periods of time for that throughput. So this basically read all of that passage and then just synthesized it into a very succinct answer for me to understand. And you can even see the context that it pulled from. So that this is all of the stuff that it read in this one thing. So I don't actually have to read all of this. I can just ask the model. And here I've now connected my external data source to this large language model. And now I can ask these simple questions. I can ask it to write blogs. I can do all these different things that enable me to now connect to external data sources and, you know, have the models basically read everything for me and just answer it without having to go through all of this like reading and writing.
And Jillian kind of mentioned it earlier. That answer is probably way better and more succinct than if I was trying to answer it. So
yep.
Yeah.
Good. Yeah. Yeah.
There's a question from Rudix World. What if I want to embed shorter strings? Does this provide any flexibility reducing the dimensions?
Yeah, so you can, so you want to output shorter strings. So the short answer right now is no. Let me explain this question. So what this person's asking is, instead of having 1500 or 1536 numbers as the output, can I make it 1000 or 500 numbers instead? So the short answer right now is no, you have to fix it to this 1536 number. But that is an interesting question to be able to compare it to shorter strings. Now, the benefit of creating shorter strings and why people want to do this is because every time you do a search and I have to calculate that 72% or 50% or whatever, imagine doing this over 1 million documents. It becomes somewhat computationally, it's not too expensive, but the larger the numbers, the more compute you actually have to use. So if I was able to output numbers as like one vector, the amount of the latency and the amount of compute you end up using would be a lot less.
Really awesome.
Yeah.
Yeah, we are almost at time. So I got one last question, and then I'd love for you to tell people where people can go. So any advice that you have for people on really how to structure a proof of concept, or if there's any best practices that you'd want to impart on the people here?
Yeah, so first of all, everything is available inside of the Bedrock console. So if you go to the Bedrock console, the user guide, you'll be able to find all of the information that you require for Titan Embeddings right there on the Bedrock console. Some best practices to just things to consider. As I go through, the database that I've created, you can see that there's different sizes of passages. So you just want to make sure that you're thinking about what size of passages you're actually chunking in at any given time. Which becomes more relevant as you have like larger and larger and larger databases of vectors that you'd want to consider, maybe being more uniform or having shorter passages, those sorts of things. So there's you can go to Bedrock, find all this information inside of Amazon Bedrock. As another plug, there's blogs here on actually how you can create practice with this actual demo. So if you wanted to go through and create your own version of this exact demo, this is also available and you can spin it up in your own instances too.
Nice.
That's cool.
I'm excited. James, are you excited?
Yeah. Yeah. I'm definitely gonna play around with this when I get a little bit of time later. Yeah. And like I said, I appreciate the explain like I'm five kind of way of doing it, because
Me too.
Good.
I needed that. Brant, thank you so much for being here on AWS On Air.
Awesome. Thank you so much for having me.